mechanisms based on the subject theory of mechanics. In that one chapter, that is a second in velocity and acceleration mechanism. In that unit have one section 2.2 Klein's construction for single slider crank mechanism. In that section we have to draw different types of velocity and acceleration diagram for the single slider crank mechanism. In that there the point that is a 2.2.1 velocity diagram by Klein's construction. In that I explain you how to draw velocity diagram for Klein's construction. Then second 2.2.2 acceleration diagram by Klein's construction. In that also I explain you how to draw acceleration diagram for the Klein's construction. And there is one another topic that is a 2.3 analytical method of velocity and acceleration analysis for single slider crank mechanism. In that there is analytical method, that is a theoretical method by using some formulas. I also explain that how to draw acceleration and velocity diagram for that Klein's construction. Now I explain you 2.2.1, that is a velocity diagram by Klein's construction. In that there is one question which is familiar asked by the MSBT in summer 2017, that is explain with NIT sketch how to find the velocity of slider in slider crank mechanism by Klein's construction. Simply we have to draw one circle, that is this is type. Simply we have to draw one circle with a suitable scale. Then we have to draw projection lines, that is the midpoints we have to know. Simply that is center line. Then in horizontal direction also. Simply we have to draw that lines extending up to very long. Then we have to draw a crank OA, that is the one center O, that is a ODC and IDC. This is. Then we have to draw certain, we have to take certain angle. If I take 30 degree, yeah. Then we have to draw one crank, a crank AO, and we have to draw also connecting rod from the point A to B. We have to take a suitable scale, but I explain you. That is A to B. B is a piston. Simply we have to draw one piston here. Piston, we have to give piston a uniform constant motion, which is successfully or completely constrained. Now belonging to the procedure, we draw this configuration diagram with suitable sketch for velocity diagram. Now we have to draw this perpendicular O to B, that is a line of action of stroke from point O, that is vertical line OC, like that. Now we extend the line AB, A to B, that is our line we have to extend, and to intersect the perpendicular drawn from the O to C, we get the point C here. And now we have to draw one perpendicular. We draw the OC, which is we extend from A to B. From the point O we get C. This crank has some certain omega, means have some angular velocity also, acceleration or velocity, that is omega. Now in triangle ACO, AO represents velocity of crank, that is a crank which represents velocity. Velocity vector CO, that is a CO, which represents velocity of piston. The velocity of piston which is represented by CO, and vector CA, that is C to A, which represents velocity of connecting rod, that is the velocity of connecting rod, which is explained by the C to A point. After that, in triangle ACO, shown by the shaded area, represents the velocity of diagram, that is a slider crank mechanism. In that we have to find a velocity diagram which is shown in shaded portion, that is velocity diagram for Klein's construction. This is a very simple, that first we have to draw the configuration diagram, then we have to extend AB as C point which is perpendicular to the O point, then we have to got ACA represent the velocity of connecting rod. This is a connecting rod which represents the velocity in the form of A to C, then O to A which represents the velocity of crank, that is the velocity of crank which have certain angle and certain velocity acceleration, that is the angular velocity, and vector CO which represents the velocity of piston which is in forward or backward direction, which is represented by the angle CO. Then this triangle which gives us CAO, which gives us velocity diagram for Klein's construction. Now I like to explain, that is the session 2.2.2, that is how to draw acceleration diagram by Klein's construction. First procedure. In that there is one procedure, that is the first draw configuration diagram of the mechanism with suitable sketch. Previous problem, in that if we find velocity, in that also we first draw the configuration diagram. This is a configuration diagram. In that previously we'll draw a line of action of stroke from the point O, and this is a point P which is a slider which is a constraint in motion. This is a AB which is a connecting rod, AO which is a crank, and AC, then AC is the connecting rod velocity, CO is the velocity of piston, and AO is the crank velocity which is moving certain angular velocity. Then draw the velocity diagram. This is a ACO which is a triangle we have to draw previous. This is a velocity triangle. Now draw the velocity diagram ACO as explained in the previous section. We already draw that triangle velocity. Then draw a circle with a center A and AC as a radius. Now we have to draw one circle as center A, like that. We have to draw this diagram as a dotted because it is a rough construction. Draw the another circle with the midpoint AB. Now we have to draw another circle with the midpoint AB. That is the one midpoint. We also plot that. Now we have to draw another circle for acceleration diagram. After draw another circle with midpoint AB, point D as a center. Now we have to plot that point as a D, and another circle have A, that is a midpoint. Intersection point of both circles be labeled as MN. Intersection, that is one point M, and that is one point N. Join the points M and N. We have to join these M and N points we finally join MN. To get the line MN, we get this line MN. Extend the MN up to the line of action of stroke, that is a line OB. We have to extend this MN up to the line OB. We have to find it, then we have to join. If we get the point L at that section, we get point another, that is a L. This is a N and this is a L. Also locate the point of intersection of line MN and BC labeled as X. This is a point of intersection of line MN and BC. We have to name as X. Shaded area of quadrilateral AXLO. We get one quadrilateral, this is AXLO. Now we have to shade it and we have to very dark some section like that. This is the acceleration diagram. Now we have to shade it. We finally get the acceleration diagram. Now we get shaded area for quadrilateral AXLO represents acceleration diagram of single slider crank chain mechanism. That is, we get acceleration diagram for single slider mechanism by Klein's construction. Now in the quadrilateral AXLO, vector OA, that is a vector OA, which represents radial component of acceleration of point A, which represents, that is, we have to A R suffix AO, that is radial component of acceleration of point A. Vector X, that is a vector X, which represents radial component of acceleration of connecting rod, expressed as ARBA suffix BA. Then vector X to L, which represents tangential component. This is a tangential component of acceleration of connecting rod, which represents tangential, that is ATBA. This is a tangential component of BA, this connecting rod. Then vector LO represents absolute acceleration, LO, which represents absolute acceleration of slider P with respect to O, BO. Finally, we understood how to draw the acceleration diagram by Klein's construction. Very simple. First we have to draw one configuration diagram, then you have to draw velocity diagram like that, ACO. Then we have to draw take a midpoint O to the connector A to C or A to A, A to B. Then we have to draw one circle, then another circle as the center A. Then join is intersection of circles as M to N and extend its line to the L point. Then we have to got one midpoint like that, B to A, M to N, that is the intersection point X. Then we have to draw that quadrilateral AXLO. This is an acceleration diagram for Klein's construction. After explaining the velocity diagram and acceleration diagram by Klein's construction, now I point towards the analytical method of velocity and acceleration analysis for single slider crank mechanism. In that particular section, there is one question which asked by MSBT in summer 2014 and 15, that is, for the single slider crank mechanism, state the formulae to calculate by analytical method. First, velocity of slider. Second, acceleration of slider. Third, angular velocity of connecting rod. And fourth, angular acceleration of connecting rod. Also state the meaning of each terms. in that particular session there is a formula. There is no any type of particular calculation, which is we draw the velocity and acceleration. We have to study only the formula, like we have to revise that formula, each term and each meaning of that is which have to conclude in that. That is first we have to draw the slinger slider crank mechanism as shown in the figure. In that one, connecting a rod, crank, and that is a piston which is constrained in motion. Let R, this is a R, which is the length of crank OA. R is the length of OA. L is the length of connecting rod A to B. Then N, that is the obliquity ratio, L upon R, which is a constant. Theta, that is a angle of turn by crank from inner dead center, that is a IDC. Then phi, this is angle phi, it is belong to the connecting rod and the line of action of stroke, that is a P to O, which shows the angle turned by the connecting rod from the line of action of stroke. Then XB, that is a displacement from IDC to ODC, XB for the slider. Using the following formulae, various parameters is used in analysis of single slider crank mechanism can be calculated. Now I explain you the different types of formula. That is, first, horizontal displacement of slider or position. Second, velocity of piston VP versus slider versus VS. Third, acceleration of slider AS or piston AP. Fourth, angular velocity of connecting rod. And fifth, acceleration of connecting rod. First, horizontal displacement of slider or piston. In that, when the crank OA, which turns an angle theta from IDC towards the ODC, then the displacement of the slider or piston can be given as XB is equal to R in bracket 1 minus cos theta plus R in bracket n minus square root of n square minus sin square theta, bracket complete. Then second, that is a velocity of piston VP or slider VS. It can be obtained by differentiating the above equation with respect to time. This equation we have to differentiate with respect to time. After differentiate this equation, we get Vp, that is the velocity of piston or velocity of slider, is equal to omega into R. This is the angular velocity into radius of OA in bracket sin theta plus sin 2 theta upon n, bracket complete, where the n is oblique ratio, which is equal to length of connecting rod upon length of crank OA, that is R, n is equal to L upon R, which is constant. Then third, acceleration of slider AS or piston AP. It can be obtained by, this equation can be obtained by differentiation above equation with respect to time. Means which is similar, that where there is a displacement, then velocity, then acceleration. We have to find out velocity with respect to displacement. We have to differentiate at this equation from the time, with respect to time. Then also we have to find acceleration. We have to differentiate this velocity with respect to time. Then we get acceleration of piston or the acceleration of slider is equal to omega square into R in bracket cos theta plus cos 2 theta upon L, which is oblique ratio. Fourth is the angular velocity of connecting rod. That is omega of connecting rod is equal to omega of AV is equal to omega cos theta upon oblique ratio, that is n. Then fifth, angular acceleration of connecting rod. That is it can be obtained by differential above equation of angular velocity. We have to differentiate it, then we get alpha of connecting rod is equal to alpha AB is equal to minus omega square sine theta upon n. That's the oblique ratio. Thank you.